Okay, this is the remaining examples from the 1.3 notes. This is example 3. We skipped over a couple of these in class. This is the multiplying section. There'll also be another piece just in a few minutes with the factoring section. But this is example 3 on the first packet that has 1.3. And we're trying to multiply out this polynomial of a binomial times a trinomial. So 7x times x cubed would be 7x to the fourth. 7x times negative x squared would be negative 7x to the third. And 7x times 6 would be 42x. I'm going to use a different color. Now we have to do negative 4 times everything in the second part. So this would be negative 4x cubed. Negative 4 times negative x squared would be positive 4x squared. And negative 4 times positive 6 would be negative 24. We do have some like terms, so the final answer would be 7x to the fourth. Negative 7 and negative 4 would be negative 11 x to the third. And we have a 4x squared. We have a 42x and a minus 24, and none of those had any like terms. There's my final answer on that one. We also skipped number E in class, or part E I should say. This one is just a binomial times a binomial. X squared times x squared is x to the fourth. X squared times negative 16 is negative 16x squared. 1 times x squared would be positive 1x squared. And 1 times negative 16 is negative 16. The like terms are in the middle, so this would be x to the fourth minus 15x squared minus 16. Okay, so I'm going to minimize this section, and we're going to open up the other piece that had the 1.3 in it, which was the section that was over factoring. There were a couple of those examples we skipped over as well, just trying to get through one of each type in class. So we learned that there were different ways to factor. Factoring out a GCF is always the first thing you check for. Looking for, if it's a binomial, looking for perfect squares with a minus sign between them, or perfect cubes that either have a plus or minus between them. There were formulas for those. Trinomials, there were an easy and a hard method, but essentially all of them can be done by factor by grouping, or the AC method was another name we called that. And then the four terms have to be done by factor by grouping. So we did A, B, and C in class. We talked about how D is prime because it's perfect squares, but it's a plus sign in the middle. And we also did E in class. So that leaves us with a few extra examples I wanted to work through, just of driving home the concepts. Notice in this first one up here, F, this is a binomial. It does not have a GCF, different variables. So we're looking at, is it perfect squares or perfect cubes? Because I see this cube here and the 27, looks like we're dealing with perfect cubes. Be careful, the cube root of x to the sixth means what would you have to split it into so that you could cube it? Well, if you want to cube it, you're dividing it by 3 essentially. So the original would be x squared, and this would be a 3 and a y. So it looks like we're dealing with an x squared is our cubed root of this, and a 3y is the cubed root of that. So remember, in perfect cubes, it's a binomial times a trinomial. Essentially, you take these two cubed roots and you write the sign in the middle. So this would be our binomial. For the other pieces, we have to do combinations of the pairs. So x squared times itself, x squared times 3y, and for the final one, 3y times 3y. So x squared times x squared is x to the fourth. Your sign always changes here from the original binomial, so this would be a minus. 3x squared y, and then always a positive for the last sign, because remember, SOAP, same as the original, opposite to the original, always positive, and that would be 9y squared. So there's that one. G is 4 terms, so we could try to factor by grouping. try to pull something out of each pair. It looks like there's an A and a Y in common for the first pair. That would leave me with a 2, a Y, and a minus X. The second pair has a 3 and an X in common, and it leads with a positive, so we'll pull out a positive sign. That would leave me with a 2, a Y, and a minus X. So because you get a matching binomial in the parentheses, that means that our final answer is that match is one of my answers, and the parts in front of each of those is my second part. And again, it doesn't matter which one you write first. My typical go-to is to write the one that was a match first, but it doesn't matter. Note about H that you can pull a 5 out at the very beginning, and that's important because if you don't do that, you'll have to pull it out at the end. So let me actually create a space here on that one. I'll do it both ways. I'll do it where I pull the 5 out first, and then I'll show you what happens if you don't catch that and how that affects your final answer not being completely factored. So for the first case, I'm going to pull the 5 out to the front. So that would leave me with an x cubed plus a 2x squared minus a 4x minus an 8. I'll try to factor by grouping on these 4 terms. Just remembering that my 5 is part of my final answer. This would be an x squared, and that would leave me with an x plus 2. This pair leads with a negative, so we have to pull it out, and it has a 4 in common, which will change that to positive 2 when we divide by negative 4. So that makes this answer 5, an x plus 2 that they had in common, an x squared minus 4, and then here's where you have to be careful. I'm actually going to add another line in. If you're not paying attention, it is very, very often going to happen that you will get something at the end that is not completely factored. This is 2 perfect squares with a minus sign between, so actually this factors again into the square root of x and the square root of 4, once with a plus and once with a minus. So remember, this x plus 2 was this one, and this came from these 2 perfect squares with the minus sign between them being split up. So another way to write this in shorthand is anytime you have a match, you write it with an exponent. So there are 2 x plus 2's, and then the x minus 2 would come down. So that would be one way to write my final answer. Now, let's say you forgot to pull the 5 out at the beginning. So this is if you forgot to check for a GCF. Then you would have paired them up just the way they were, because it's still 4 terms, so that means it's factor by grouping. So you would have said, okay, I can pull a 5 and an x squared out of the first pair. That would leave me with x plus 2. I can pull out a negative 20 out of the second pair, which leaves me with x plus 2. The x plus 2 they have in common. And then you get this. Notice that this is not completely factored because both of the things inside the parentheses are divisible by 5. So you would then have to pull that out to the very front, divide it out of this, so that would leave you with x squared minus 4. And you see the trend again where you get the x plus 2 and the x minus 2 to go along with what you already have. So either way, you can get the right answer. It's just you may not remember to check at the end, so it just can be problematic. And then we have I and J. I'm going to move them to a new page. Just wanting to bring that ink with it. See if I can delete that out. Just keep the ink from following us all the way down. There we go. Okay, so let's look on the next page. We have another 4 by 4, or 4 terms. So this is trifactor by grouping. Pull out an x cubed out of the first pair. That leaves you with x minus 3. The second pair leads with a positive, and it has an 8 in common. That also leaves you with x minus 3. Problem here is that when you pull your x minus 3 to the front, you're left with perfect cubes, and you have to check for that. So this has nothing in common, but this is perfect cubes. So we'll still have our x minus 3. Cubed root of x cubed is just x. Cubed root of 8 is 2. So our binomial and our trinomial will have an x and a 2 with a plus sign because the perfect cube part is plus. Then we have to do x times x, x times 2, and 2 times 2. So that would make this x squared, minus, so we have to do opposite sign of the original. So minus 2x in the middle, and 2 times 2 is always positive, and it is 4. So that would be my final answer on that one. Okay, last factoring problem. Start with a GCF. You can pull out an x, and that leaves you with 4x squared plus 4x plus 1. Notice this is a trinomial, and it has a non-1 in front, so we need to do 4 times 1, which is 4. Factors of 4 are 1 and 4, 2 and 2. We're looking for a pair that have the same sign because this last term is positive. So they're either both positive or both negative, and they add to 4. So the add to 4, you'd have to be 2 and 2. So that would then, the x is still out front, but this would be 4x squared. We expand the middle, so it's a 2x and a 2x. We factor by grouping. You can pull a 2x out of the first pair. If a pair have nothing in common, you have to pull something out. So we just pull out a 1 and whatever sign this leads with, so it's a positive 1. And note this time that we get the x out front because of our GCF. We get a 2x plus 1 from the matching parentheses, and we get another 2x plus 1 because of the parts out front. So this one is actually x times 2x plus 1 squared. And that's it for the 1.3 part.